so again, I'm not here Monday.
Who's your sub?
My sub is Mr. Griman. So, Mr. Griman will walk through a couple examples. He knows how to do basic trig stuff because he taught it for years.
Here's a math teacher.
Yeah, he's taught math and science of interest. So, all right, so here's the idea. He knows the basics. He doesn't like the wave graph stuff, even though I think he had to teach it in chemistry or physics. He knows it. He'll probably just put a couple examples on the board and say, here it is, moving on. So those are the problems that you probably have to kind of figure out. I will already have a video online. I know this seems really weird. I'll already post a video from Monday's lecture online. I'll just post a video from last year. I'll just add it right to the slide. So if you want to watch me like walk through something very similar to what we're doing, you can watch me like from a previous year go through it. But it's one of those things I just want to make sure that you guys get a chance to work on some problems. Later in the week, the homework will be due. That way when I'm back, I'll answer questions and we'll go through stuff you're not getting. Next Thursday, in here, we have a test. Thursday, in here, we have a test over chapter 1. Up to this material.
Are we getting a study guide?
Okay, yes, we'll get a study guide. Mr. Graham should hand it out on Monday. If he doesn't, I'll hand it out Tuesday and we'll do the 2-day review like we always do. Okay? I'll already have it on the website. I'll add it today after school, so if you want to download it, you can just click it and it'll open up in Google. The problem is, it may, like, the picture might be off, because I use, like, special characters through Microsoft Word. I'll try my best to make it work with Google Drive, but I'll put that, but he'll hand out a physical copy, and then we'll do the review Tuesday, Wednesday. But homework that we get Monday, because you're not getting homework today, but Monday's homework will be due later in the week. That way you can ask me questions and keep working on it. Does that make sense? Okay, so we got a test coming up very, very soon next week. Okay, let's do a couple notes here. I want to do 2 triangle problems where you have to solve for a missing wall, and then the rest of the day is just wave graph stuff. So here we go. All right. So first one here, let's draw this. Let's go with x. Let's go with 5, and this is a 63 degrees. That is a right triangle. Okay. This is something that was brought up yesterday. I wasn't planning on doing this so soon to talk about it, but it was a question, it was a very honest question that was brought up yesterday. It was a good question. I want to address it today. So when you do these problems, I recommend that you do the trig functions, SOHCAHTOA, right? So you go through SOHCAHTOA and we try to figure out what to do on this problem. So when we label it, right, you label and it tells you which one of the 3 formulas we have to do. So on this one, this is the opposite wall to my angle. This is the adjacent wall to my angle. So I'm looking for the one that uses opposite and adjacent, because I'm not using a hypotenuse here. It's the only wall I'm not using. So opposite and adjacent, that's this one. That's how I do it. That's the quickest way to see it. So I'm doing TOA. So tangent of your angle is opposite over adjacent. Second letter on the top, third letter on the bottom. So opposite in my case is 5. Adjacent is the x. How do I solve that from yesterday? What was the shortcut?
You flip flop.
Switch what?
X and 63 degrees.
Good, we switch these 2. Then you have to figure out how to type that in your calculator. Most calculators are very straightforward. It's in degree mode. You can type it and hit enter. If you don't have the luxury of a scientific calculator, you'll have to figure out what the tangent of 63 is first as a decimal, then take 5 divided by the decimal in order. 5 divided by that. Okay, that's what you have to do. So you might have to write stuff down. Now, what number are we getting? What decimal? Say again? 2.55?
Yeah, that's right.
Okay, so everyone's getting that. I'll go with it. Okay, so here's the idea. Is that right, or you just make it though?
It's 2.547.
Okay, I go with it.
Yeah, dude.
You gotta get 3 decimal places.
What you
Yeah,
don't.
3 significant figures.
Alright, now, here's the idea. Now that we have my numbers, here's the question somebody asked yesterday. Do we have to do the trig functions? Because I think it was Mariah did it. She did the law of sine. And it came up with the same number.
Wait.
Yeah.
That's what yours is.
The law of sine works on any type of triangle, not just a right. Right are the trig functions, normal trig functions like that. But the law of sine, law of cosine, like that stuff, works on any type of triangle, including a right. The law of sine, if you don't remember that, law of sine, that's where you take the sine of an angle, sine of some angle, over its opposite wall, sine of another angle, over its opposite wall. and then you just solve the proportion. Well, we happen to know what we had because I gave you enough clues yesterday. We can fill the numbers here, right? The 63, this angle up here in the corner has to be a 27. That way these add up to be 90s because the triangle has to be complementary for those two.
Whoa.
And now I can go sine of 63 degrees over its opposite wall, which is 5. Sine of the 27 degrees over its opposite wall. You cross, multiply, divide, and it gives you the same digit, 2.55. It works just because the reason what it's doing is it's making right triangles by doing this. It's solving that triangle, it's solving this triangle, and then solving for x. It's going across the picture, that's what it's doing. That's what we explained in pre-calc a long time ago. But a lot of people never made that connection. Like they're going to give you the same result because this formula works on any type of triangle as long as you know how to set it up. Questions? It was just a good question because it was something we just don't think about every day. All right, we good with that? Now here's my question to you. Do we need another one of those? Or do
Yeah.
we feel comfortable with
No.
signing?
One more.
We're good. Hey, can you draw it the other way though?
Can I bring my sheet? If I have my sheet, can I
Cheat
use it on the
sheet?
test?
Yes, I'll eventually give you that.
Hey, Ward, can you
Oh.
draw
One
it the
more.
other way though?
One more.
Which one?
Like, put the angle like this way with the line going, the hypotenuse going this way.
Like this.
Yeah, do one of those.
Okay. Let's go with x. Let's go with 12, and let's go with 24 degrees.
Thank you. What about 55?
Hey, 24 is my
I'm
favorite
waiting for
number.
55.
All right, so going through the numbers here. Figuring out which trig function I have to pick. I have to label, so I have the 24, my angles from the 20, or my walls from the 24. This is the adjacent, this is the hypotenuse. So it looks like adjacent and hypotenuse, I'm using that one, the cutoff formula.
Can you do the sine, law of sine on this one too?
Yeah, you can do the wall sign, it works on everything.
So what's the point of teaching?
These are the fastest ways, the bare minimum digits you'd have to type in. It's like to me, doing the original trig functions is faster than the law of sine. Because you don't need all the extra stuff. Because you need like 3 numbers to type in, cross, multiply, divide. But this way only requires this. It requires cosine of 24 is x over the hypotenuse, adjacent over hypotenuse. And then all I have to do is multiply by 12. Done. Like that way is faster to me than the law of sine. Some people like the law of sine. I don't mind. If you want to use it, use it. I don't care. It's the same number, as long as you know what you're doing.
What happens if you don't have that second? What do you do?
If you don't have the 24,
Yeah.
then you go over here and
What about
Match
like,
24?
no, if you don't have that one?
you just don't have that.
Yeah, how do you find,
You wouldn't be able to do it. You don't have enough numbers.
you know what I mean though? So you have like all the walls,
Oh.
how do you find the?
Okay, so if you have all the walls, so you have a 6, and you want to find that angle there.
Yeah.
Okay, cosine of x adjacent over hypotenuse. Inverse cosine though.
That's what I was thinking, alright.
That number should be 30. Questions?
What's the formula for the law of cosine?
Law of cosine is the wall you're trying to find squared equals the 2 other walls squared add together minus 2 times the 2 walls cosine angle between them. So it looks like, yeah, it's a thing. X squared equals a squared plus b squared
Oh, that's
minus
just the Pythagoras.
2ab cosine the angle between them.
Well, you could use that there.
So you can use law of
Yeah,
cosine
that's-
for that.
Technically, you could.
Oh, we had to use that on a test. That's a test I did not do that
That'll open up that way.
Which
Alright.
one did you do good on, Abby?
I like the law of
Nothing.
cosine.
All right, let's walk through my next type of problem. We got to do the wave graphs. The goal today, we got to introduce tangent. I'll do an example. I'm going to do a review question for sine or cosine. It really doesn't matter. I'm not going to do both. I'll just do one. We're going to review tangent. That's something I didn't do yesterday. Then we're going to do the ones where we shift it right, left, up, down. We're going to put everything into one row. The right and left idea is the most difficult thing we can do in pre-calc and calc when you shift right and left because there's so many weird mechanics things you have to do to get the right markers. in the right spots. Okay, so here's the idea. We'll start with, I'm just gonna review one of the problems we did yesterday. 2 cosine, let's go 3 pi x plus 1. So this is a review question for cosine. So in this particular case, this is the amplitude, that's how tall the waves are. This is the period or frequency, so that's my 4 hash marks going across. And this number is the shift, and this is going up. Going up because it's a plus. So going through the mechanics of cosine, the first thing I always do is figure out where to shift. Well, I don't have to worry about right and left on this one. How I know that, there's nothing added or subtracted inside the parentheses. That shifts it right and left. So I'm shifting it up 1. So there we go. There's that midline again. You don't have to put that dash line out. I like to have the middle line to know where it's at. From there, how far up and down am I going? 2. 1, 2. So I'm hitting 3. 1, 2. So I'm hitting -1. So 3 to -1. That's my amplitude. It's 2 from the middle line, wherever you're shifted that. Now the period or frequency is the 4 hash marks going across. Typically, we hit 2 pi. That's usually the 4th marker. But whatever's out front of your x, that's what you divide by. So in my case, it's not a fraction. Like yesterday, you guys had fractions. I'm just dividing by a 3 pi. The pi's cancel, so my 4th marker is 2/3. It doesn't even simplify. It's just a nice weird number. It's a fraction. Question?
What if we don't simplify?
It's fine. If you don't simplify, you just leave it. I'm fine with that. You're showing me that you at least know what you're doing. You set it up. I don't really care about that. Divided by 2, basically if I put a 2 on the bottom, that's 2/6. That's how you divide by 2, just put a 2 on the bottom. 2/6, which is 1/3. Cut it in half again, that's 1/6 by putting another 2 on the bottom. And multiply that by 3, so I get 3 on the top, 3/6, which is half. That's 3/6, which is half. So it's half multiplied by 3. And I simplified them as I went, sorry. Did that all in one swoop. How are we good so far?
Yeah.
Drawing the wave graph. Cosine starts at its highest point, goes to 0, goes to its lowest point, comes back to 0, goes to its highest point. It looks like a big U shape, or if you turn your head, it looks like a C. It looks like a parabola, but it's going to go right now. Okay, are we good? Okay, now let's get to the more difficult one. Let's get to tangent. Tangent. I'm gonna throw all my numbers in here. Tangent. Let's go 4x plus 2, and I'm gonna put a 5 out front. So I'm really throwing the deep end with tangent. All right.
How deep?
I do it for you.
Pretty deep.
12,
About 2 up and about 5 deep.
That's not bad.
All right.
That's
So.
a nice food.
Okay, so here we go. Tangent normally goes over 0. There's 2 hash marks this way, 2 hash marks this way. Tangent centered over the origin. Now the 2 hash marks don't go out to 2 pi and they don't go to -2 pi. The full length of tangent normally is pi in length. It's pi, not 2 pi, like this one usually. So since the whole distance is pi, the entire distance is pi, this is going to be pi over 2 and -pi over 2. Because those add together to make a full pi all the way across to be made in positives. And then we cut that in half, that's pi over 4 and a -pi over 4. That's the full distance is 1 pi all the way across. That's normal tangent. Tangent has asymptotes on the outsides. Then you draw it like this where it kind of goes through the middle. It's supposed to hit here. It's supposed to hit the amplitude still at 1 and -1. That's where it hits here and here. That's tangent. It looks like an S shape, but it hugs right against these asymptotes. It never crosses it. It'll hug right up against it, so it has an undefined boundary. The reason why is you're going to be eventually divided by 0, so that's undefined at some point.
Wait, so isn't that one like all connected?
Yeah, this is all connected. So this would just keep going. It would just keep oscillating up and down. This
So-
one's disconnected. There's literally individual pictures on the graphic calculator where they're not connected. The idea is that this one really mimics the idea of like a cubic graph. That's what it looks like. But it's it's going up to positive infinity. It's going down to negative infinity. It's not actually not going right and left. There's a limit to it where it stops, has a boundary. Okay, but let's do all the weird stuff to it. So what we're doing is we're gonna be moving this thing up 2. We're gonna be messing with the 4 hash marks going across to figure out the amplitude, all that good stuff. So if I shifted this up 2 spots, so this is 2, this is where my dash line is gonna be. We're gonna have a couple hash marks going this way, a couple hash marks going this way. We'll figure out those hash marks here in a minute. The outside hash marks are the asymptotes. That's how I always know it. It's gonna hit a peak of 5 and -5 below that. So 1, 2, 3, 4, 5. I'm not drawing a scale. 1, 2, 3, 4, 5. So it's gonna hit -3 and it's gonna hit a +7 up. And that's where this is where tangent's actually going. Starting up here at positive infinity, it's gonna hit 0 here and then go to negative infinity. But it's gonna hit these amplitude numbers at the first marker. It's hitting these amplitude markers at those. So it's gonna hit 7 at that first marker and it's gonna hit -3 at that other marker. Because that's my first hash marks going across. That's one length.
Dude, that's not what
For what? Oh yeah, that's a little bit off. Quite a bit actually. Let's put that here, that's my first hash marker.
that one's good enough.
So where I'm hitting those marks are, that's the 5 above and 5 below, I'm hitting them at the first markers. That's why I know that. Okay, now, to figure out these 4 hash marks going across, what is the normal length all the way across?
It's a pie.
Pi. Normally pi. But what we do is we divide by the number in front of x. So we're dividing by 4. That is my distance all the way across. So I'm doing pi over 4 all the way across.
So 8.
So yeah, so we cut this in half. So this is pi over 8, pi over 8. Half and half on each side. We cut that in half again, pi over 16, pi over 16. There you go, done. Tangent, once you get going, tangent's straightforward enough. You just have to remember it's going a full distance of pi, not 2 pi. Knowing how to set up those 4 markers, we cut them in half again. All right, questions? Now let's get to the real doozy.
This wasn't the doozy.
Not even close.
This is the doozy.
Let's get to the real doozy. Very
Which one is this last one?
low. And then
This might be
walks
all
up to the
right.
camera.
You're not gonna do another tangent one?
I promise.
You're swearing in class?
Wait,
I am not cursing, but I am
You're
swearing.
swearing. Seriously,
we're not
in
doing,
class.
we're not doing another tangent.
I think
Not another tangent.
we should do a cotangent.
He just turned it off.
I'm not doing any of the reciprocals.
We ever done the
Those are more
reciprocals?
fun.
We did it in pre-calc.
Are they just backwards or what?
Yeah, they just kind of go off of these. You got the
Oh,
original
that's like the,
Yeah.
dude, I never knew how to do those.
Well, yeah. All right. Here's the last problem of the day. No joke, last one. I want to shift right and left, up and down. We're going to do the sine graph. We're going to do sine graph. And now what we're going to do is we're going to mess with it, shifting it right and left. And I'm going to put all the numbers in here. Let's go with 3x plus 2.
No.
And let's shift it up 1. And let's put an amplitude of 3 out front. Okay. This is a doozy. We have everything mixed. The hardest part about this problem is the stupid 4 hash marks going across. Because this thing is actually being shifted to the left a couple spaces. Okay? The 2 here is actually shifting it to the left, not 2 perfect spots. Let me explain. Normally sine, if I draw the normal sine graph, it does this. It starts at 0, it goes the 4 hash marks across, ends up at 2 pi, right? And it hits a peak of 1 and -1. That's what sine normally does. But what we're doing is we're shifting this 0, this new starting point, we're shifting it by this. Both numbers in there is where we're shifting. It's not just the 2. The 3 also affected it because it's been stretched horizontally. So here's the idea. How I always figure out where my starting point is.
What do you mean by that?
Start point.
When it starts.
Like where
No.
sine normally starts.
Not that.
What?
So you're shifting both of them, wouldn't it just be?
Both of these numbers affect the starting point. It's not just shifting it left 2. The 3 also affect it because we're not on 0 anymore. We're not on 0.
We're on 2.
So it's been stretched like 1/3 the distance again. because the 3 also affects where the horizontal is affecting. So, because anytime there's numbers on the inside, and it's silly. So, all right, so here's the idea. How you figure out starting point? Take this parenthesis and set it equal to 0. I want to figure out where the new 0 is. So set it equal to 0. That's the easiest way I can explain it to you. So where I'm going to end up at, I'm going to add it, or subtract the negative 2 over. I'm going to divide by 3. This is the new starting point. Starting at negative 2/3. That's where I'm going to start. So my graph, starting at 0, 0, will start at negative 2/3 to the left. So here we go. So we're starting negative 2/3 to the left. This is where my graph will start, and it's going to go up and down and do that normal sine thing. But the problem is, I have to figure out where the 4 hash marks are going to go. That's the part where this is messy. It literally will take a scientific calculator, like a calculator that you have right in front of you, and we have to type everything in to know if I'm getting positive or negative numbers, to figure out where the 4 hash marks are. Because I'm not going to land at 2 pi anymore. It's been shifted. And I don't want to just subtract 2/3 off of it, because I want to get the exact number. So how you figure out where we're going to land is, this is the goofy part. I have to resort, no joke, I have to think about what the original graph would have done if I didn't shift it right or left. This is how I get it in my head. I have to figure out what would the original graph have done if the stupid 2 wasn't sitting there, if it was just a 3. Because that's how I'm going to figure out my hash marks. This 3 really affects the period. This just affected the horizontal shifting. Okay? So, this 3. So normally we'd hit 2 pi, right? So what we would normally do is take this 3 and divide it, right? This would be like the 4th hash mark down the road, in theory, right? Because that's without thinking about shifting it right or left. That's just dividing the 2 pi by 3. But I have to figure out what the first hash mark would be. So cut this in half. That's cutting in half, right? Simplifying it. And then cut it in half again. And then if I multiply that by 3, this would be pi over 2, right? Does that make sense how I got those hash marks like normal? Cut in half, multiply by 3.
Can you teach me how to multiply by a fraction?
When you multiply this by 3, just put a 3 on the top and then simplify.